Myself, Rajendra S. Karale. My qualification is MSc Chemistry BEd and experience is of 28 years. Now, today we are going to discuss about the application of Le-chatelier's principle. That means to determine the direction of equilibrium, whether equilibrium shifts from left to right or right to left by taking one of the typical example, that is here twice NH3 gas gives N2 gas plus thrice H2 gas, and here delta H of theta is equal to plus 92.38 kilojoule. Now, this is the reversible reaction. For the forward direction, delta H is positive. That means here heat is absorbed. That means given reaction is endothermic in the forward direction, while the same reaction is exothermic in the backward direction. Now let us apply first condition. Here write down case 1. If concentration of NH3 is increased, here NH3 is the reactant, that means concentration of reactant is increased, or concentration of N2 or concentration of H2 is decreased. Now in this case, N2 or H2 is product. Now here equilibrium of the reaction will shift from left to right. Second, case 2. If concentration of N2 or H2 is increased, that means here concentration of NH3 is decreased. Here equilibrium of the reaction shift from right to left. Third, if pressure is increased, now here keep in mind the most important point is that pressure is increased means volume is decreased, because volume is inversely proportional to the pressure. Volume decreases means number of moles of gaseous system per unit volume is increases. That means here the equilibrium of the reaction will shift in the direction in which number of moles of gaseous system per unit volume is decreases. That means here equilibrium of the reaction will shift from right to left. You can also determine directly here number of moles on the reactant side are 2 and that of product side are number of moles of gaseous reactant are 2 and that of product side are 1 plus 3 is equal to 4. That means reactant side have low pressure and product side have high pressure. Here pressure is increased. That means equilibrium of this reaction will shift in the direction in which pressure is decreased. That means from right to left. In a similar manner, let us consider case 4. If pressure is decreased, means volume is increased. That means volume is inversely proportional to the pressure. Volume is increased means number of moles of gaseous system per unit volume is decreases. That means here equilibrium of the reaction will shift in the direction in which number of moles of gaseous system is increases. That means here from left to right. Now same concept. Here pressure is decreased, meaning is that equilibrium of this reaction will shift in the direction in which pressure is increased. Low pressure, high pressure, that means here left to right. Then write down next case 5. If volume is increased, now effect of change of volume is exactly reverse to that of effect of change of pressure, because volume is inversely proportional to the pressure. That means case 5 is similar to that of case 4. That means here left to right. Then case 6, if volume is decreased, now let us observe case 5. If volume is increased, that means number of moles of gaseous system per unit volume is decreased. That means here equilibrium of the reaction will shift in the direction in which number of moles of gaseous system goes on increases. That means from left to right. Now if volume is decreased, now effect of change of volume is exactly reverse to that of effect of change of pressure, because volume is inversely proportional to the pressure. That means case 6 is same as that of case 3. Here right to left. Or in another way, volume is decreased means number of moles of gaseous system per unit volume is increased. That means equilibrium of the reaction will shift in the direction in which number of moles of gaseous system is decreased. That means from right to left. Then write down case 7. If temperature is increased, temperature is increased means equilibrium of this reaction will shift in the direction in which heat is absorbed. That means endothermic reaction, so that the temperature of the system is decreases. Or endothermic reactions are always favored with increase in temperature, and here this reaction is endothermic in the forward direction, that is from reactant to product, that is from left to right. Here equilibrium of this reaction will shift from left to right. Then next, if temperature is decreased, in this case equilibrium of this reaction will shift in the direction in which heat is evolved, that means exothermic reaction, so that temperature of the system is increased. And keep in mind, the exothermic reactions are favored with decrease in temperature. Here the given reaction is exothermic in the backward direction, that is from right to left. Here equilibrium of this reaction will shift from right to left. Then next, case 9. Now here effect of catalyst. Now catalyst does not shift the equilibrium from left to right or right to left. This is because that catalyst affect the rate of forward reaction as well as backward reaction equally. That means no net change occur in the relative amount of reactants and product at equilibrium. That means here write down no effect. It helps simply to achieve the equilibrium quickly. Now here, next, case 10, effect of addition of inert gases like helium and neon, etc. Now, effect of addition of inert gases like helium and neon are considered at two different conditions: at constant volume and at constant pressure. At constant volume, there is no effect. While at constant pressure, when an inert gas like helium or neon is added to the gaseous system, volume of that gaseous system goes on increases, but the number of moles of gaseous system per unit volume goes on decreases. That means here equilibrium of the given reaction will shift in the direction in which number of moles of gaseous system goes on increases. Now let us observe the reaction here. Number of moles of gaseous reactant are 2 and that of gaseous product are 1 plus 3 is equal to 4. That means here at constant pressure the equilibrium of this reaction will shift from left to right. Now here effect of addition of inert gases like helium and neon at constant pressure is applicable only when the number of moles of gaseous reactant are not equal to the number of moles of gaseous product. But it is not applicable when number of moles of gaseous reactant is equal to the gaseous product, that is H2 gas plus I2 gas gives twice HI gas. Here number of moles of gaseous reactant are 1 plus 1 means 2 and here gaseous product are also 2. Now same condition is also applicable to the effect of pressure or effect of volume. That means effect of pressure and effect of volume is also considered only when the number of moles of gaseous reactant is not equal to the number of moles of gaseous product, but pressure and volume do not have any effect on the equilibrium if number of moles of gaseous reactant is equal to number of moles of gaseous product. Now this is regarding about the application of Le-chatelier's principle to this reaction. That means in order to determine the direction of equilibrium whether from left to right or right to left. Here you are. This unit gets completed and remaining part will be discussed in next period.